Okay, so for the chapter 6 test here, we're going to review sections 6.1 through 6.3 and 6.5. And in 6.3, we learned how to do long division, so we're going to remind ourselves of how to do that here. When you do long division, you always want to make the front part match the front part of the other. So in this case, 3x needs to be multiplied by 2x squared in order to equal the 6x cubed that we want. Then you take your 2x squared times the other part of it, and that gives negative 10x squared. Okay, we're supposed to subtract here, and I taught you that it's usually more reliable when you change that to adding the opposite. And in this case, the first term cancels, which is what you want, and you get negative 18x squared when you add those. Bring down the next digit and continue the cycle, or the next section. And we're still trying to match this front one here with this front one. In order to do that, you're going to multiply by negative 6x. Negative 6x times 3x does indeed match it. You want it to match now. Later, when you change the signs, you'll be canceling them. So the negative 6 times the back half of this is going to be positive 30x. Okay, now the procedure tells us to subtract, but we prefer adding the opposite. Our first two cancel, and you get 12x after you add those last ones. And here comes a negative 24 joining the dance. All right, so we're back to trying to match this front one with this front one, and we'll just multiply by 4. So plus 4 here. That does indeed match 4x times 3x. And 4x times minus 5 at the top there is negative 20. We will be subtracting, but it's more reliable, generally speaking, to add the opposite. And sure enough, we canceled what we wanted to cancel, and you get a remainder of negative 4 here. Let me write that down a little better. So when you have a negative remainder, you put a minus and a 4 over what we've been dividing by all along. And we have our quotient up there at the top. It doesn't include that part. Okay, so there's our quotient, and that does it for example number 16. Okay, on this next one here, we're supposed to divide using synthetic division. You take your divisor, set it equal to 0, and then that tells you x has to be negative 2. First number copies, multiply by that negative 2. Add those, multiply by the negative 2. Add those, multiply by negative 2. Add those, and you know your remainder. Just back up. We're going to put the negative 2 over the divisor we've had. X plus 2 was our divisor. And the 4 is a constant. The negative 6x goes next, and then you back up and put an x squared on the other one, and you have your quotient. Okay, we're going to do the same thing on the next one, but there's a missing column, and you got to watch for that. There's a 0x missing. So the numbers are 2, 8, 0. That's not a very good 0, but anyway, and negative 23. Okay. And if you set x plus 3 equal to 0, you get an x of negative 3 in the angle bar. So the first number copies, multiply by negative 3. Add, multiply by negative 3. Add, multiply by negative 3. Add, and you've got your remainder of negative 5. So this is going to be 2x squared plus 2x minus 6 is your constant, minus 5 over the divisor x plus 3. There is your quotient. Okay, so let's see what's next here. We're going to determine whether the binomials down below are factors of this long polynomial there. And I've got the coefficients already set up here, so let's see if this is a factor. We'll stick x equals -2 right there. Copy the 4, multiply by -2. You get -22 multiplied by 2. Add those, you get 57. Multiply by -2, you get -114. And add those, you get a remainder of -135. And since that's not a 0, you're going to say no, not a factor. That's simple. Okay, we'll see if the next one works. This time we'll put a, let's see, x minus 3 equals 0 would yield x equals 3. So copy the 4, multiply by 3. Add those, multiply by 3. Add those, multiply by 3. And this time we get the desired result. So yes, the binomial is a factor of the other one. Okay, and so that does it for, let's see, what do we cover here? 16 through 20, I think is what that was.